in this video I will teach you how to make your very own automatic three-phase selector, and we won't just build automatic three-phase selector. So we'll be adding SMS alert to this device, so the device will send us SMS each time it switches from one phase to another. And for protection, we are also adding overload protection, so we don't overload the very useful device. So what are we waiting for? Let's start. Alright guys, so in order to construct our circuit, we will have to put everything together using this diagram. Okay, so before we move over to the construction, I have actually designed my own PCB for the circuit. This is homemade. I have designed it using the very old PCB wizard. It works very well for me. And switching here, you can actually see the common of all the relays are connected as explained in the circuit diagram. And then here you have the various inputs. So we have the red, yellow, and blue phase input, and their common is connected together to the output. And for the GSM module, I'm actually using SIM800l version 2. And of course, one very important thing you probably noticed is that I'm using the bare chip, and I'm actually using ATmega8 microcontroller. The initial design was made with the ATmega 328P in mind, but the absence of that actually made me connect the RX pin straight to the TX pin of the microcontroller. So you can actually use this if you have the 328P chip. If you're using the ATmega 8, you have to follow the circuit diagram. Every other thing the same. So, all right, let's move over and construct our circuit. All right. So for the circuit, I'm using the ATmega 8 microcontroller, and you can actually use ATmega 328. They are pin compatible. I have a lot of this lying around, so I chose to use one. And here we have the power supply. I'll be using this 300 milliamp transformer to power the circuit. So we have the red phase coming in here, the blue phase, and the red, yellow, and blue phase. Of course, the filter capacitor, voltage regulators, 12 and 5 volts. And here are the transistors to tell the microcontroller which of the power supply is available at the moment. Here is the programming interface, and this is just to filter the voltage switching on the transistor. This is 0.1 microfarad capacitor. Here, of course, is for my FTDI programmer to program this chip. LED input indicator, output indicator, overload indicator. And here we have three 10 amps relay. And here is ULN 2003 IC for the relays. And here's my SIM800, and of course you can see I'm not using the proper antenna. I had one but used it for something else, so I'm using the spring antenna. I realized this is also not very sensitive, so I added a piece of wire to improve the sensitivity, which actually worked very fine. Here is a, should I call it a storage capacitor for the GSM module, and here's my ACS712 current sensor. Actually, this ain't bad. I'll make a video of this. And I think that's the whole of the circuit. Yeah. Okay, so I am done. I'm done with it, and gotta adjust the camera. Okay. All right. So let me zoom in, and okay. So everything has been connected. Here I have this teeny tiny little transformer. This is 300 milliamps, 300 milliamps. This does 1 amp, and yeah, this is an overkill, but it's what I've got. So I've connected the transformers, their inputs. You can see I also use a tiny little color-coded wires for the input, red, yellow, blue, and then the neutral. Also, I have connected the same inputs to the relays. The output of the relay I have connected. Let me turn on this light. Okay. So the output of the relay I've connected to this current sensor from the current sensor connected here, and that's the live output. The neutral goes straight to the outside here, and this is just how it's gonna be. So that we have live, neutral, and the different inputs. All right, so I think the next thing to do after now is to program it. So I'm just gonna connect the rest of the things here. This is the output indicator. Let me zoom out a bit. Okay, this is output indicator. This is overload indicator, and we check the load level using this. The ACS712 current sensor. This can do 30 amps. I wouldn't do it near 30 amps. I'm actually running it at say 10 amps max. I doubt it will get to 10 amps anyway. And this is the input indicator. So here the input is connected as common cathode. So input indicators will, the microcontroller will source to the indicators. The same thing with this, but this is connected as common anode, which means it will sync. Okay, so let me just plug everything in place, and this goes here like so. Okay, and okay, this also goes here like so. And actually, I didn't take note of the polarity of this, so I'll just put it in whichever way, and I'll hope it's the right way. Alright, and one more thing, something is lacking, and that's the lack of SIM card for the GSM model. The SIM card can enter from here. I currently don't have any spare SIM card, but I tested it with my SIM card for my phone, and it worked very well. Yeah, let me show you the SMS. Move it up here, move it up here. Okay, so if I raise it up a little bit, you can see the SMS aspect, and briefly we'll go to the code window and you'll see how this SMS came. Yeah, all right, so let's move over to the code window and program this beauty. All right. Okay guys, so here on the code window, first of all, we have our library, and then here we set up the libraries. On the first side, we have our input, and this is the pin the current sensor is connected to. Here is our supply voltage to the board. In our case, it's 5 volt. So if you are working with the, say, node MC ESP32, you change this to 3.3 volt, as that will be the reference voltage. And then here we have the resolution. This is 8 bits, so this is our resolution. When we move to the ESP8266 10 bits, we'll change the resolution to 4095, and this is the sensitivity. So the higher the current, the lower the sensitivity value. So for instance, if you're using the 5 amps variant, you have a bigger sensitivity value. That's actually in the example code of the library. And then here we have our pin configuration, the input pins and output pins, and then we go to our variables. These are the variables that will be used in the code. This is for our timer, so we will use this for the timer, the current sensor. And then the next thing, the pretty normal aspect, we set the different devices to either input or output. Of course, here we initialize our serial monitor. Every other thing pretty normal. And then here we test our GSM module. You can see we did not use software serial here, and that's because of the microcontroller in question, the Atmega 8 microcontroller that I have chosen. You can actually use software serial. And then here we are redefining certain things. So we assign the read input state to digital read input, the same with the yellow and blue, and these are for the various phases. And then here also we initialize the current sensor, and then we do our load check. We'll get to that soonest. And then here you can see we check our input state for the red phase, and we turn on the indicator depending on the input state. The same thing we did for the yellow and the blue. And then this is our overload protection section. So if the system is overloaded, this is the part of the code that comes to play. Otherwise, this is the part that comes to play. And then we go down. This is nothing but the serial print, serial debugging section. This is our load check, and the load check actually waits for 5 seconds, and then it checks the load current to make sure the device is not overloaded. Okay, this is the load current check. This waits for 5 seconds before setting up the load current check. So you can see after the time frame, this part of the code will run. After the time frame, we have the load check code. You can see it's actually called here. And then the load check just checks if the value is equal to or above the threshold. Now our relay is rated 10 amps, and we really don't want to run 10 amps, so we check the value. And since this is in milliamps and not in amps, we have 9000 for 9 amps. So anything above 9 amps, equal to above 9 amps, we turn the load state to 1, else it will remain 0. And taking you back, now you can see where this becomes the overload protection control section. When load state is equal to 1, this part of the code gets called. And then we go to our auto switch, and this is where the switching takes place. We check the different conditions, and then we switch accordingly. You can see for every switching SMS is sent, every single switching, and we have 8 different conditions that might occur here. Here we have 1, 2, this is 2, we have 3, 4, 5, 6, 7, and the last one, but not the least, 8. So you can see this is the end of the code. 8 different conditions, and you can actually go through the conditions. They are pretty self-explanatory, and that's it for the code explanation. So we'll go ahead and upload the code and see how our circuit works. Okay, so the code has been uploaded successfully, and now it's time to test our work. I have connected this 100 watts incandescent bulb to the output, and at the input I have connected, gotta be careful with this. Now I've connected this, and this is connected to my socket outlet of 220 volts AC. And the neutral, I have also secured it to the neutral point, so I'll be playing with the live wire. And this is live. Look at it. Is it? Can you see? You see? 205. That's a lot of voltage. Alright. So at this point you do it at your own risk. And this is the incandescent bulb. And don't forget output. This is RGB, overload, red, blue face, yellow face, red face, neutral. And I will start with the blue face. Blue face input, and 5 seconds. So you see it's on, the output is on. Let me keep it here. And here you can see blue for blue face. Output is also blue. Yeah, shift this a little bit. Okay, you can see very well now. Let me keep this here. So output is blue, here is blue, and I'll go to red face. That's the reason why I'm skipping yellow face. So I'll move to red face, and 5 seconds later it will come up. Okay, so you see red for red face, output is red. Okay, now for the yellow face, don't forget this is RGB, and while you can actually get a whole lot of colors using PWM, I'm only switching. So for that we are only having red, green, and blue. And so the yellow face is indicated as green here. Like so. Let me put it. Okay, 5 seconds, and so you see yellow face is green, and here you can notice it's yellow face. Alright, so that's it for this project, and I guess we are done here. I'll just put everything together, close the box, and ready to deliver. Alright, thanks for watching. See you in the next video.